variable system. Now this handout is one that I want you to try to do on your own, but I know some of you are going to get a little bit stuck, and so you might need a little bit of help, so that's what I'm doing in this video. I'm not going to work out every single problem. I'm going to start with number 2. The first thing that I like to do is label each row. Row 1, row 2, row 3. And that's what R1, R2, R3 stands for: row 1, row 2, row 3. The next thing is you look at the problem and you try to decide, is there anything that I could do substitution or elimination that would make this a pretty easy problem, or at least easier. So as I look at this, I'm looking at R1 and R2, and I think if I subtract R1 minus R2, then that will give me a pretty straightforward answer. So I'm just going to subtract that, and I can show that work here. And so I did say subtract, but if you want to think of it as multiply R2 times -1, we can do that. So if we multiply this times -1, then we're going to make all of those negative. And now when we add these straight down, the y's are going to drop off. We are left with a z equals -1. Okay, I'm 1/3 of the way done with my problem, right? I have my z answer. Now when we give our answers, we always want to give them in the form of x, y, z. It is a coordinate. It's a coordinate. It's a place in a three-dimensional plane where you can, or a three-dimensional space where you can find that point. So z is -1. Now, what else? Well, again, I want to try to start with the most simple things I can start with. So if I look at row 1 and row 2, those to me look a lot easier than row 3. Now, I can see that row 3 might be tempting because that z is all by itself, and you might think, well, let me put that in there and then I can solve this. But think about it. If you did that, you would still have an x and a y. Whereas if we chose the 1 or 2 instead, we would have the y and we'd have an answer. I'm just going to choose row 1. And so I'm just going to plug in that -1 in for my z, and I'm going to work this out. So I get y minus 4 is equal to 2. I'm going to add that 4 to both sides, and that gives me y equals 6. Once again, that is a solution. I'm now 2/3 of the way done with my problem. I'm going to put my 6 in that second spot. We always go in alphabetical order: x, y, and z for that term, for that coordinate there. Okay, I have my y, I have my z, I still need an x. As I look at my 1, 2, and 3, the only thing that has an x in it is row 3. And that's actually good in a way. I always want to use all 3 of the equations. If you only use 2 of them, you're going to be missing out on some information. So try to make sure that you've included all 3 of them in your work. Okay, so now I'm just going to take my z, plug it in for z, take my y, plug it in for y. So do you notice I'm using my R3? I labeled it here so that we can see what I'm doing. That is really helpful to you. If you will label your work with these R1, R2, R3s so that you can go back, because if you make a mistake, it's going to be very difficult to find that mistake if it's unorganized. So I try to stay as organized as possible. Okay, I've plugged in my z, I plugged in my y, and I'm going to go ahead and solve it now. All right, so I get 12 minus 17, which is -5. So I need to add that 5 to both sides. So when I add the 5, I get negative 1 plus 5, that's 4. 4 equals negative x. Of course, I have to divide by negative 1 to get x equals negative 4. So I'm going to go back up to the top. I have negative 4. So my answer to this problem is negative 4, 6, negative 1. That is the solution. Keep in mind as you're working on these, try to do some with elimination, some with subtraction. I know some of you prefer one over the other, but try to use the one that's going to make the most sense. So like for instance, on number 1, substitution would make more sense. But on number 2, elimination made more sense. So look at the problems and try to decide what's going to work best. One other tip, you're trying to get down to where you only have 2 variables that you need to solve for. So for instance, R1 and R2, I only had 2 variables, so I could go right away. Like that was easy setup for me because the 2, I only had a y and a z, so it's easy to solve for. It's not easy, but we learned it, so now we know it. And then once I can solve for one of those, then that gets me down the road a little bit farther. Now, again, I'm not going to work out every single problem for you, but I'm going to show you a couple of hints. Like on number 3, for instance, what I see in this first one is a 4x with 3 variables. In the second one, I have a negative 4. The third one, I have a negative 4x. So I could maybe do linear combination with R1 and R3 and break that down. Okay, on number 4, I'm looking at this last equation, and that looks, I think I can get a start with that. So you have to look at the problem. You have to take some clues. You have to decide whether you're using substitution or elimination or maybe both. And then you have to try to solve down to 2 variables and then down to 1 variable from there. And then use that to plug back in. It is a complex process, but I know you guys can do it. And some of you are actually going to find it kind of fun because it's almost like a puzzle, like you're trying to figure out all the puzzle pieces. It's a lot of fun. So I hope this helped. We were going to be working on this a lot in class together, so if you have questions, please speak up, bring your questions, and we can work it through together.